Hello and welcome. This is a lesson on air masses. Get ready to learn. I'm going to be using this map of the Earth. Okay, we got a lot going on here. Did you know air mass is a large body of air that has about the same conditions throughout? And we do that so that we can see and talk about general things regarding these air masses. You can see that there are some similarities over where they are and if they're over water or if they're over land. So an air mass is a large body of air that has about the same conditions throughout. Air mass takes on the conditions of the area where it forms. That makes sense. If you're going to have area over the water, it's going to be holding more moisture than area over, say, a desert. And most air masses form over polar or tropical regions. So we have the poles, north and south, and then this area around the equator, the tropical area. Now, why is this important? Well, the weather is always changing. Weather changes because of moving air masses. And air masses generally move from west to east. That's due to the rotation of the Earth. So, we have an air mass here. It's called maritime polar, and we give it abbreviation, so it's kind of like a shorthand. The first letter is lowercase, the second is uppercase, so you can tell them apart. The M is for maritime, and you can remember that by M being moist. It's moist air. The P stands for polar, so it's cold. So remember, they're named after where they're formed. So it's over the water, maritime, polar, cold. Let's look at a air mass down here. That would be MT. M, maritime or moist, but tropical, warm. So we have MP, MT. Moist, cold, moist, warm. It's because they're formed in different places. Now, if it forms over a continent, like here where there's desert, it's going to be dry and it's going to be warm. So you have continental, it's formed over a continent, not a lot of moisture. And tropical, because it's in this equator area, so it's warm. So you have dry, warm air. Now you have continental polar. So you have maritime polar, maritime tropical, continental polar, continental tropical. So you have dry air, remember, over the continent, but formed at the pole. It's cold. Okay, you have it in the northern hemisphere and the southern at the same, don't forget the southern hemisphere. So, they're named after where they're formed. Now, because they move, they generate wind. And we have some general winds on the Earth. You see the direction here, and this is because air is being heated, it's rising in the atmosphere, and where it cools and forms these bands. So on the surface, they're going in this direction. On the surface, here's another set. They're going in this direction. And you can see on the southern hemisphere, they're reversed. And this is due to the spinning of the Earth as it rotates. And, of course, the air being different temperatures and moving around. Cold air masses tend to move toward the equator from both poles. That makes sense. It comes from the pole and goes towards the equator, where it heats up and then comes back. Warm air masses tend to move toward the pole from the equator. So you have a warm air mass here, it tends to go towards the pole. You have a warm air mass here, and it tends to go to the pole. Right here. Rises at the equator and then tends to go toward the pole, or the North Pole, South Pole, North Pole, depends on where you are on the surface. The winds are named by the source direction. So if you have a wind that is a northern wind, it is coming from the north. So we have some general winds on the Earth, and you can see that they're split up by cell names. Think of different bands based on different temperatures. Now, the jet stream. You may have heard of that. It's a fast-flowing river of air at the top of the troposphere. In other words, it's at the top of the weather band is a river of air that pushes. It pushes the air fronts. You can see in this map, here is the jet stream, and you can see it pushing the air mass. And it generally flows in a meander from west to east. Fast-flowing air. It's like a river. And it changes. Like everything else, it changes. So when air masses meet, cold air mass moves south from the pole, it runs into a warm air mass moving north from the tropics. The boundary between the two air masses is called a front. You might know this from a battle. When two armies meet, they meet at the front. Masses usually don't mix at a front. They're different kind of air. High pressure, high density air, low pressure, contains a lot of moisture. The differences in temperature and pressure causes clouds and precipitation. Now you've got the clouds condensing and forming into drops. So we got something going here. Let's decode this. You got the direction of the frontal movement. The symbol on the map are these little arrows, and it indicates the direction the front is moving. So we've got advancing cold air behind a cold front. High density air, receding warm air ahead of the cold front. In other words, this is hanging out, and this cold air front bumps into it. Now, cold air is more dense than warm air, so it's going to push underneath it, lifting the clouds making go into a colder area, which will cause condensation. And this is where storms come from, when air masses meet. So, why is knowing about air masses important? The weather is always changing. The weather changes because of the moving air masses, and air masses generally move from west to east. There's your lesson on air masses.